then add your standard deviation. So this is 375. Add it again, you get 425. Add it again, you get 475. Now you have all of these values. Then you go backwards and go 275. Go backwards again, go 225. Go backwards again, and you get 175. So all I'm doing is adding and subtracting 50. And then once you have that, then you can answer the questions. Okay? If you remember, this is 68. This is 95. And this is 99.7. And then it says 68. Well, what's 68? Well, 68% is between these two. So then you just have 275 and 375 as your answers. And then the next one says, well, what values do you have between 175 and 475? So 175 and 475. Well, that's 3 standard deviations up, 3 standard deviations down. You just write 99.7. Okay? Those are the two easy problems. The third one, the usually C and D are the more challenging ones. What percentage of organs weigh less than 175 and more than 475? Well, less than 175 is here, more than 475 is there. Well, you already know how much is between them, so outside them is really just 100 minus 99.7 is 0.3. And then D says, what percentage of organs lay between 175 and 425? So this is probably the most challenging problem, the 175 to 425. So that corresponds with here and here. Well, the answer is somewhere between 99.7 and 95. Well, what we do know, if I draw at 0, this is half of 95. This is half of 99.7. So you just add those two together. 99.7 divided by 2 plus 95 divided by 2, and that gives you 97.35. When I was going over this, I said the only math you really do is subtract from 100 and divide by 2. That's all the math they're doing. All right. Next one. Which one we want?
3.4.14.
A certain company throws away more than 4 standard deviations from the mean. Okay, and you are told the mean is 14 and standard deviation is
0.05.
0.05. Alright, so these two are related. So this would be 1 standard deviation, 2 standard deviations, 3 standard deviations. So we just gotta get to 4 standard deviations. And we gotta get to 4 standard deviations below. So for this, all we need to do is we take the mean and we do whatever z they give us, 4 standard deviations, plus we gotta subtract it. So this is a formula that we use a lot, where x is mean plus or minus the z that's given to us times the standard deviations. And this is what we end up doing. So we get 14 plus or minus 4 times 0.05. Well, that's 14 plus or minus 4 times 0.05, 0.10, 0.20. So then that becomes 14.2 and 13.8. So this is for standard deviation, so it's anything less than this and anything more than this. Make sure you do put those in numerical order. Alright, which other one? People only ask questions about 3 of them. What was the other one? I don't remember what number it was.
Can we do 3.3.4?
3.3.4?
Mm-hmm.
Yeah, I don't know if I'll need to calculate that. Alright, middle of 25 and 35 is 30, middle of 35 and 45 is 40, and then that pattern continues 50, 60.
And you got that from doing the 25 minus the 35, right? That's how you got the midpoint, right?
No, the middle of 25 and 35 is 30. I look at the 2 lower ends, and it will give me the midpoint of the
Okay, so
values.
25.
That is the right class. Alright, so we go to our stat, edit, clear my list. Clear my list. What's good about this one, it's only 4 data points, but we do 30, 40, 50, 60. And then we do 25.7, 35.9, 36.6, 20.2. And then we go to stat, and we go to calculate one variable statistics. Make sure you have list in list 1, and make sure you're pulling the frequency from list 2, and then hit calculate. You're asked to round to 2 decimal places, so I'm gonna be lazy. So change my float to 2. And then I have 44.33, and we are told that this is the entire population. You can look at these symbols and say it's the entire population. So make sure you use this one, the 10.10. As you notice, there's a bunch here, so they don't even give you a sample. Okay.
Thank you.
Any other questions?
Thank you.
None from Chebyshev's? Man, that was the most important.
So 3.237 would be related to the 3 point, like the same thing, right? What you were talking? No?
In 3.233, you are told it's normal bell shape. In 3.237, you are not told it's bell-shaped, so you have to use Chebyshev inequality.
Okay.
That's the difference between when we know to use empirical and when we know to use Chebyshev's. So did Mr. Jones tell you open notes? What did he tell you?
He knows, whole page front and back.
Oh, nice. Hopefully you got small handwriting. There's a lot you can cram
I
into
didn't know that. Okay.
8.5 by 11 times 2. What I would recommend, as a math student who knows how to write teeny tiny, as you are doing your review, do it with
what I'm
one
doing.
single sheet of paper. Whatever you write on that review,
It's your cheat sheet.
or what you could use on that test. If you use more than one sheet of paper, then take those 2 sheets of paper and try and condense them down to 1. Alright? But if you're using it, whatever you are having to look up on your review, write it on this piece of paper, and then you will have that for test day. Alright? Alright, Chebyshev. I really think it's weird that Chebyshev uses K. It really makes sense to me to use Z,
Yeah, so standard deviation.
because that's really what we're using, but he used K. Alright, in A, we're told price from 3 standard deviations. In B, we're told price from 1.5 standard deviations. In C, we're told, what is the, standard deviation or percentage from, and we're told
2.94.
294, 318.
Yeah.
Okay, and then we also need to make sure we understand what the mean is and the standard deviation is. The mean is given as $3.06, and standard deviation is given to us as 6 cents. So first thing is 1 minus 1 divided by number is 3 squared. Times 100. Alright, 88.89. One method was around 2. Good, 2 decimals.
9, yeah.
Alright. So that's pretty quick. Next one.
Again, I didn't square.
All we do is change the 3 to 1.5. And then it's 55.56. And then a lot of people struggle with finding the prices, but you know the mean and standard deviation and the Z. So again, we're using that X
Plus or
times
minus.
mean plus Z times standard deviation, where it's 3.06 plus or minus 1.5 times 6 cents. 1.5 of 6 is 9 cents, so 3.06 plus or minus 9 cents. So that would become 315. And subtract 9 would be subtract 6 and subtract 3, $2.97. So you're paying somewhere between $2.97 and $3.15, 55% of the time. And then the last part gives you the 318. So take your 318, subtract that from the mean, which is 306, and you get 0.12. Well, 0.12, how many standard deviations is that above the mean? Bye-bye.
Yeah.
Divide by 0.06. You get 2. Because that's 12 cents above the mean, that's 12 cents below the mean, which is 2 standard deviations. So now that we know the standard deviations, or really the z, is equal to 2, well then we just plug into 1 minus 1 over 2 squared times 100, and that gives you 75. I've worked this problem 9 times. Sorry, 10 times. All right. I do want